Okay, our last intermolecular force to talk about individually, and then we'll start kind of folding this idea into the larger topics of the chapter. So, hydrogen bonding. So this is the strongest intermolecular force we're going to talk about. And so it's going to involve things that have OHs, NHs, and FHs in them, which in the case of FH, guess what? That is the molecule. You can't put an FH group on something. So yeah, you don't see that very often. You dissolve that thing in water. That's hydrofluoric acid. I think I talked about it with my 221 class, but it goes straight to the bones, turns them into jelly. So it's not like your normal acid where it burns the skin. It doesn't really burn the skin. So terrifying to work with. I've only had to do it once, never again. All right, so what happens is, this nitrogen has a lone pair, that oxygen has 2 lone pairs, fluorine has 3 lone pairs. And it's an interaction between the lone pairs and the hydrogen that's bonded to something that had those lone pairs. So water is a hydrogen bonding machine because these H's receive hydrogen bonds and these O's send them out, or vice versa, however you want to. Depends on your perspective. Now, if you have something with like a double bonded oxygen, we'll mention this. It doesn't have the ability to hydrogen bond by itself, but it can receive hydrogen bonds from water. So it can half hydrogen bond. It's like a half hydrogen bonder. So just a little note there. This is like a half H bonder. Just be aware of that. So it doesn't have an H to send out, but it can receive them because it has the lone pairs. All right, so our hydrogen bonding is going to increase in force, have stronger interactions as we have more H bonding groups. That's kind of the first thing. So for example, if we have something like this guy right here with 2 OH groups on it versus something like this guy here, same length of carbon chain, but only 1 OH group, this is stronger, because it has 2 OHs versus this one only with 1. So this is going to have stronger interactions, going to have more intermolecular forces. We'll talk about what that means moving forward in the subsequent sections of this chapter. And then the last thing is OHs are going to have stronger hydrogen bonding potential than NHs. So if you have something like this guy versus something like this guy, so you have like something with NHs and something with OHs, everything else is the same. Stronger interactions right there for the OHs. So just be aware of that. But yeah, so that's kind of the last one. These are very strong attractive forces, by the way. Water is not a large molecule, but hydrogen bonding holds it into a liquid. And in temperatures that we can experience ourselves, gets it down to a solid. But maybe you don't know what I'm talking about yet. We're going to talk about in this section. That's all about like phase changes and things like that. So just hang in there. This will be the last video I shoot today, so next time I'll have a different t-shirt on or whatever. So enjoy.